Here we have a word problem. We have the perimeter of a square is given by the function perimeter is equal to 4 times the square root of the area A. So if our perimeter increases, that means our area is going to increase. And if our area increases, that means our perimeter is going to increase according to this function. Okay. So the first step is to graph the function, and so how can we do that? Well, we can make a chart, right? Just like we did with all these other problems, except instead of x and y, we're going to be using p and a, right? So we'll say p and a, make a chart here. And so we need to have values under the radical sign that are not negative. So our a is going to start at 0, right? Oh, I think I drew this wrong. I think it should be a on the left side and p is on the right side. Okay, so it's a and p, right? So our a is going to start at 0, 1, 2, 3, and 4. So 0's square root of 0 is 0, so 0 times 4 is 0. Square root of 1 is 1, so we get 4. Square root of 2 is 1.41, so let's do that on a calculator. Square root of 2 times 4 is 5.6, and then square root of 3 times 4 is 6.92, and then square root of 5 times 4 is 8.94. So let's go ahead and graph these. So at 0, 0, 1, 4 is here. 2, 5.6 is going to be right about there. Yeah. And then 3 is going to be 6.9. So it's right about there. And then 4 is going to be 8.94. So right about there. I think I misjudged this one there. Okay. So let me go ahead and connect these dots, and we get a function that looks very much like the parent function, except a little bit off, and determine the perimeter of a square with an area of 225 meters squared. So our p in this case is equal to 225 meters squared. So we just need to go ahead and substitute that in to our equation. So that gives us 225 meters squared is equal to 4 times the square root of a. So how do we solve this? Well, we need to isolate the square root. So we're going to divide both sides by 4. And so what do we get? Oh, we get a fractional number. Again, let me get my calculator here. So 225 divided by 4 is 556.25 is equal to square root of a. And now to solve for a, we need to square both sides, right? So I'm going to square that side. I'm going to square that side. And so what do I get? I'm going to square 56.25 times 56.25 is going to be equal to 3,164. And then this is going to be meters squared is equal to a, right? Because the square root of a times the square root of a is equal to a. Yeah, that sounds about right. So we know that the square root of a times the square root of a is equal to the square root of a times a, right? And to break out of square root jail, we need two factors under the square root that are the same, and we have them, so it's equal to a, right? So I went ahead and substituted in a for square root a squared. So that is our answer here. That is our area if the perimeter is 225 meters squared. Now, the question is when will the perimeter and area have the same value? What value is that? Okay, well, that's an interesting problem. Since we have this function, what we're trying to find is when is p going to be equal to a? So what I can say here is I could say p is equal to 4 square root p, right? When are these two variables going to have the same value? So let's use the same variable for a and p and solve for p. So how can we do that? Well, we'll go through the same process. We'll isolate the square root. So we'll divide by 4, and we'll get p over 4 is equal to square root p. Now we're going to get p by itself, so we're going to square both sides. And we'll get p p squared over 16 is equal to p. All right. So now what do we do? Well, we can multiply both sides by 16. So we get p squared is equal to 16p. And now we're going to divide both sides by p. Right? And we'll get p is equal to 16. Okay. So when will the perimeter and area have the same value? It's when the perimeter and area are both 16. Are both 16. There we go. So let me go ahead and put a box around it is equal to area.